Hi there, my name's Luke Gorry, and this Snabb Braindump is all about making the sausage. So this is not really an end user kind of a thing. This is more being done to give context to people who are contributing to a current effort to do a kind of large scale performance analysis and optimization of the Snabb software. So I'm going to zoom way out and talk about how we're putting that effort together, so that everybody kind of understands the full picture and what that means for the part that they're working on. So in order to use this as an effective communication mechanism, I'm going to treat this as a live stream. So if I make mistakes, I'll just keep on going. So you have been warned. So lots and lots of testing effort in Snabb at the moment. So we've developed our software Snabb that we develop continuously. We've set up a continuous integration server called Hydra, which is able to run tests on a really kind of a large scale. So we have in the Hydra cluster about 25 servers available for running tests on, and we're starting to do really big test campaigns where we can define several thousand combinations of configurations and workloads and such things, and have this executed at a pretty high throughput so we can get an answer kind of the next day. And the Hydra then, so the Hydra runs a lot of tests, creates archives to publish all of the details, all of the logs, everything for each test run, and also does a little bit of reporting. It generates CSVs and it generates visual reports. And then the next step in this is the Snabb Studio, which is the next bit that we need when there is some kind of an anomaly, a test that fails or that doesn't give the performance that we expect, is different than the results of the other tests in an unexpected way. Then it's crucial to be able to zoom in on that and understand what's going on and see what needs to be corrected. If there's some kind of an infrastructure issue with the lab that needs to be fixed, or if it's something caused in software that is basically a bug that needs to be fixed, something like that, we really need a productive way to take the logs from a run that has not run in a good way and find out what's going on. And I've done a previous video about this timeline feature for the logging that creates these million entry, very precisely time-stamped logs for analysis. So, first component, if we just take these components one by one, Snabb and then Hydra and then the Snabb Studio. So Snabb is a piece of software that sends network packets around. You think of it like a switch or a router. Snabb, this process here in the middle, it runs on Linux and it connects up to some number of network interfaces. In this picture, which illustrates the stuff we're going to be looking at in this video, we have one Snabb process that is connected to two physical network cards, NIC A and NIC B, and it's also connected to two virtual machines, VMA and VMB. So in this scenario, Snabb is providing the connectivity. So if this virtual machine wants to talk to this virtual machine, it will send the packet to Snabb, go through there and back again. So Snabb is responsible for getting the packets through to their destination, and it has the opportunity to apply policies, to do IPsec encryption, or to apply packet filters, or to apply tunnels, and all of these kind of things. So that's what we're looking at here. Then hopping over to Hydra, that's what we have up above. This is something that's just a public thing on the internet, our continuous integration homepage. It's pretty new, but we've got some tests here. So what we do with the Hydra is, as I said before, we define some tests that we want to run, ask it to run them, ask it to archive the results, including logs of each individual test that it ran, and ask it to summarize the details. If I hop over here, we have a result of one such run, a relatively small one. I mentioned that they go up to thousands of combinations. This is just for 120 different tests. So Hydra has run these individual steps. That's one benchmark there. If I click on that, I get the logs for that particular benchmark run, and likewise and likewise. There's 120 of those, and then up above we have a CSV file that Hydra has generated to give us the summary of all of those, and we also have a report, a HTML report, which is generated from the CSV if you're not in the mood to do it, load it into Excel or something like that. So if we open up this report and go down to the HTML file that's provided, then we can see what is it that happened in this benchmark run. So here's just a little summary. So Hydra ran, as I mentioned, 120 tests in total, and that is with 6 different benchmarks, Basic 1, Blast, 64, and so on. And for each of those benchmarks, it did 20 instances, which lets us see is there, if we just take one measurement, it doesn't really tell us if we have any variation and that kind of thing. So the reason we do many is so that we can see variation. And you can see here that's really important, particularly on the blue line is the really interesting thing here, the iPerf 1500. In this test, we've had a Snabb process running and two virtual machines, and they've been doing a TCP transfer between the virtual machines through the Snabb, and we just run that for about 10 seconds and then see what throughput they got. And it's very interesting to see here that most of the time it was in the kind of 13 to 14 gigabits per second range that they saw, but in this case, number 9, it's very conspicuously below. There's a couple of others that look suspicious as well, and this is the most extreme one. So what we want to see in a test like this is just a straight line that shows perfect consistency at some performance level that we think is appropriate. And that's not what we see here. So this is a case where we need this next step, the Snabb Studio, to say what happened in number 9. Let me see the way test run number 9 behaved so that I can compare and contrast that with case number 10, for example, and see why did 10 get 14 gigabits per second and 9 got only 10 gigabits per second. So this is where the Snabb Studio is a crucial thing to be able to answer these questions quickly. So now if I would go back to this page, I can scroll down and find instance number 9 of that benchmark. It happens to be this one here. So as I mentioned, for each test run we have all of the logs archived, so I can click there and I can see the little text log summary. Okay, that's a bit of a sanity check. Yes, this got 10.1 gigabits per second. It is the one that we were thinking of. And then from there I can download this state tarball, and inside there I will find a file called timeline, and that is the file that we load into the Snabb Studio. This is a log file that contains up to 1 million log entries, and it's a binary format that has some interesting information. So if we hop over to the next window, I've loaded this timeline file into the Snabb Studio, and I'm just going to look at the simplest view that we have in the Snabb Studio, which is the textual log, none of the visualizations right now. So here, this is the log of what happened from the beginning. So the first log message occurred at this time here, which is measured in CPU cycles. So a tick of this is less than 1 nanosecond. So it's very precise logging. We started processing traffic, and then 468,000 cycles later, we logged the message saying now we're starting a breath. Breath is what we call an iteration of the event loop. This column here, the lag, is just telling you the time delta from one message to the message before, which requires a little bit of interpretation to know what to think of that. So it initializes the breath 3,000 cycles later. It has initialized the first network card 24 million cycles later. That's pretty interesting, just in browsing through to see the kind of order of magnitude of some of these things. So when you do have an event here that takes 24 million cycles, on the one hand this is actually a really short time, this is only milliseconds, and it is kind of reasonable. There's a reasonable explanation in the sense that it's initializing a network card, but generally this is the kind of thing that should be able to catch your eye in the log. This is something that took a long time compared with the surrounding things. Initialize the other NIC, and so on and so forth. We see here in a very kind of fine granularity what's happening in the log, and I just draw attention to a few messages. So this start of breath and end of breath are really significant. This is an iteration of the event loop. So normally when we find an area of interest, it'll be one iteration. We'll say, well, something fishy happened in this iteration. We might say that for this one. We say, well, we had a really long time we spent on one of the messages in this iteration. So it will be interesting to kind of look at that range of entries there and say, okay, that was initialization. That makes sense. We kind of you can see what the explanation could be for that. And then another thing that's a bit funny here, you see a very long time here from the end of that breath to the start of the next one. Now this is because of the way the logging is done. So I mentioned that the log can have up to 1 million entries, but you use up 1 million entries very quickly when you're logging at this rate. So we're only talking about a matter of seconds normally. So what I've done is to randomize the log level. So at the end of a breath, it actually chooses a random number and has a low probability of of logging the next breath. So what that means is that when you get this start, the reason it's such a long time there, such a long lag between the end of that breath and the start of the next one, is just because logging had been disabled for a period of time. So you need to just take it with a grain of salt. The lag on these start messages, and you see here start, end, start, end, start, end. The log level here is not set very fine grained, so all it's logging here is either nothing at all or the start and the end of the breath for that duration. And then you get down to one here where after the breath has ended, it's randomized the log level again and come up with a more fine grained one. So then we get some more detailed messages for a while until the end of that breath, when again is chosen a random log level and gone more brief, less verbose. So this is there's a lot of useful information in here, presumably, but what we're looking at here is like 100 messages or something, and there's up to 1 million of them in the file. So we're really looking at the trees, and what we need to see is the forest. So that's the kind of the first thing that we really need with the Snabb Studio, is to zoom way out and get a look at these 1 million entries and say, well, what is it that happened? How did the execution look? Which bits should we be zooming in on and looking at in this kind of level of detail here? We can't just start from the beginning and go to the end, because it will take us a week or something to scroll our way through the whole log. So imagining how that might look, I was thinking, just as an idea, we could have a visualization with a graph showing throughput on the y-axis, like how busy is the process, how much work is the process doing, and then time going in the other one. And depending on what actually happened during the execution, we would see one of these lines. So for example, in a fast, well-behaving one, we might see something like the red line, where, okay, in the beginning we're idle because nothing has started happening yet, and then at some point we start running a test, and the traffic rate climbs, and then it goes along at quite a steady pace throughout the test. That's what you would expect to see more or less in something that's behaving well. In the ones that behave poorly, it would be very, very interesting to know what would you see. Like, would you see something similar but lower, like this purple line that goes along idle and then starts up but doesn't really hit a very high speed, but then continues at a kind of at a consistent pace? Or would you see something like the yellow one that's kind of bouncing up and down, or the green one? So what do you see? And if you would see the yellow one, for example, then you might say, okay, this is the slowest bit, show me that. You would like to go click and see the logs there. Which component of the software is using up a lot of time there? What's going on in great detail there? And then you might want to click up here and be able to compare that and get some feeling for what is the kind of dynamic component that is changing. Is it some behavior of the network card? Is it some interaction with the virtual machine that you don't know until you look in this level of detail? And for developing software and writing optimizations, this is just totally crucial. So the Snabb Studio is what we will use. We go out to the Hydra, run like 1,000 tests. We get some number of them where we're not happy with the results. We find the worst one, we load it into the studio, we go through and we see what's going on. And that tells us, is there something in our test bed that we need to fix? Is there something in our software that we need to fix? Is there, what's going on? It gives us the visibility so that we don't have to get it out of trawling logs. So that is step 0 of this whole process. That's some context for people who are contributing to the software itself, the Snabb software or the Hydra or the Snabb Studio, and this will be context for further discussions. Thank you very much.